Hello, today we're going to try to explain the tire covering problem. The question is, how many ways can 1 by 2 tires cover a 2 by n area? The 1 by 2 tire could be vertical or horizontal. Okay, so actually in this question, this is in the category called recursion or iteration. Recursion means the function at the end, it depends on the function of the previous one or previous something, for example, Fibonacci sequence is a very classical recursion function because every single value at a certain place always depends on the sum of the previous two. So that's what we call recursion. And then I think iteration just means you go iterate one time and eventually you will derive there. It actually explains better in computer science language than my layman English. So I will not try to explain the difference between recursion and iteration, but I do want to covering how to totally understand this tire covering problem, okay, from mathematical point of view. So let's take a look. I am a very visual person. If I don't see it, I don't feel it. So what I did is this. I actually went to draw. So let's say it's 2 by 1 tile, and 2 by 2 tile, 2 by 3 tile, 2 by 4 tile, 2 by 5 tile, 2 by 6 tile, 2 by 7 tile, okay? So 2 by 1, you only have one arrangement because you can only fit the one vertical tile, right? No other arrangement. And then we have 2 by 2. You could fit like that vertically or horizontally. So there are two arrangements. And then 2 by 3, you could do vertical only. And then you have one set horizontal and then another set vertical, right? So you can have this two arrangement. So that's give you 3. And then what if you do 2 by 4? 2 by 4, you have this, and then you arrange like that. You will see this number actually incrementing by 1 because I'm purely rotating the vertical bar by 1 to the left. Do you see that? If you see, okay, and then you will see that because there are 4, right? So I can easily make it 2 set of horizontal one, right? So that's a new shape. And then we go to 2 by 5. 2 by 5, the first one, always the one vertical, like when you do just vertically, everything's vertically, there's only one arrangement. So you're gonna have one set horizontal, okay, and a 2 set horizontal, okay? I believe that's it. Let me see. Yep, that's it. Okay, let's go to the 6, 2 by 6. In the 2 by 6, you have one set horizontal and 2 set horizontal, no gap, and 2 set horizontal with gap, and 2 set horizontal with 2 gap in the middle. And I believe, do we have more? Yes, we do. We have 3 set horizontal, right? And then we do similar thing for the 7. So I did that. I did a 2 set horizontal connect together, 2 set horizontal with 1 bar in the middle, 2 bar in the middle, 3 bar in the middle, and then 3 set horizontal, and then no bar in the middle with 1 bar in the middle. And then I actually counted each of them, and then I add them together. It will be 1, 2, 3, 5, 6, 7, 8, up to 7. Okay, so 7 differential is my second support. And already that 4 is equal to 1, and 5 is equal to 8 equal to 5 plus 6, and 13 equal to 8. 8 equal to 5 plus 6, 13 equal to 8 plus 21 equal to 3 plus 8, right? So this is actually, everybody say, okay, I'm pretty sure the next number must be equal to 21 plus 13. And then I will see, without going further, we probably can see that equal 21 plus 13. That would be the next number of arrangement. So how do we really fully convince ourselves that we are not going to miss anything? So I would say I need a more visualization. And then when I watched this video, this instructor in the video mentioned one sentence, work from the back, backwards. Okay, I was like, whoa, that's it, backwards. I got it. Look, if the last one, let's say the last tile we're going to cover is vertical. Okay, let's use 2x10 as example. And then if the last one is vertical, then the previous arrangement must be what I cover with this light green color, right? There's no other way out if the last one is vertical. So then you can say that if the last one is vertical, then actually F10 vertical, okay, F10, yeah, F10 vertical, it's equal to F9. Oops, what did I do? Oh, sorry about that. Okay, this must be equal 9 if it's vertical, okay? Let me clean up my format real quick. Okay, and then let's say if the last one is horizontal, okay? If the last one's horizontal, then you can only come up from here because otherwise it doesn't fit, right? So once the last one is horizontal, you actually cannot do anything other than this arrangement, which is the yellow one, and it turned out to be only 8. So F10 horizontal is equal to F8. And then you combine this, okay? Then you will see that F of 10 is equal to F10 vertical plus F10 horizontal, which is equal to F9 plus F8. Oops, plus F8. Okay, and then we got it. We totally got it, right? So if we extend this to 11, to 13, to whatever, we can just change this to anything. Doesn't matter this number now, any number. And then if you want to go one more, the orientation for the last one definitely has to be, if it's vertical, has to be -1. If it's horizontal, has to be -2. Otherwise, this horizontal tile doesn't fit. That's why now we fully prove F10, the function F10 is always equal to F9 plus F8. Okay, thank you. Hope you like it. Bye.